Hi everyone! In this video we're going to discuss structures, dictionaries and tuples. So what's the aim here? We have a very messy room and it's not really sane to live in a place where nothing is in order. You need to look for things all the time and you like your things to be ordered. So ideally, if you want to find your things easily and classify them, you should tidy your room and have a nice wardrobe. Then you can order your stuff. So you would have all the jackets in one place, all the shoes in one place, and so on. So last week we learned about arrays. And arrays is one way to store information in the same object. So one thing about arrays is that they contain information of similar types. For example, an array of floats. So an array could be used, for example, to represent an array only of jackets, which would be all of the same types. But the question is how to hold everything together in an organized way. So in contrast to this, in order to construct such a structure here, we would need to be able to store jackets, store boots, store shoes, store t-shirts, and other stuff. So these are different types. For this, we will use structures, dictionaries, or tuples. So I will give you an overview of what these types are. Let's start with the tuple. I will use one example throughout the next slides. This example is when you go shopping, you have a cart, and in your cart you put different things like milk bottles and oranges and stuff like this. So the tuple is a versatile data container. So it can contain different types. And this is how to generate a tuple. To generate the tuple, for example, O, we set it equal to, take care now, we use the round brackets. And then we put some information like integer numbers, 4, 5, here D is a character, 2.0, a floating point, double quote, guy. This is a string. And that is what Julia returns, the collection of all these informations of different types. So you have to be careful here that when you generate a tuple, you don't use the square bracket as we did for an array. Here we use a round bracket. They can be accessed using an index. So if you set O, and now since it is an index, we are allowed to use a square bracket, O of 3 will return D. This is position 1, 2, and 3. O of position 3 is character, Unicode, ASCII, and the value is D. What is important to know about tuples is that since they contain informations of different types, the mathematical operations will not apply. So if in your basket you have a milk bottle and an orange, you cannot add them because they have different types. The addition would not make any sense. So they are fundamentally different from vectors or from arrays in general, because since the vectors and arrays contain information of same type, they can be mathematical operations can apply. You can add 2 tomatoes and you will have a result of 2 tomatoes. So that's very important. You will never make mathematical operations directly over the whole collection of different types. Another thing that can be done with tuple is to use the name tuples. So previously we generated a tuple with information directly there, but they were not attributed a name. So we could not really classify or classify the information. Now if you generate a tuple, which we now call basket, and we set it equal to round brackets, and inside we will define a category fruit equal orange, and orange is a string, comma, and fruit, number of fruit, is equal 1, comma, bottle equal string milk, comma, and bottle, number of bottle, is equal to 1. This is what is written: fruit equal orange, and fruit equal 1, bottle equal milk, and n bottle equal 1. If you use the index now, so basket square bracket 1, this will return orange. But you can also now use the name which we have to access this information. You can also ask basket point fruit dot fruit, and this will return orange also. So we have a new feature here. This feature is called a key. So if you want to know all the keys you have in your name tuple, so the keys are basically fruit, bottle, and n bottle, you can use the function keys, round bracket, basket, and this will return all the keys you have in your name tuple. The other part of information is the value. So fruit has a value of orange, and bot has a value of 1. If you want to access the values in your name tuple, you type values of basket, and then it will return orange, 1, milk, and 1. So the tuples are very nice, especially name tuples, because it's an easy, almost single line generation of a versatile data container. And due to the diversity of types and the easiness to handle, they are very popular. So, and they are also used in different languages. They are very practical ways to store and organize data. Now another very popular type, which we also will use in the lecture, are the dictionaries. So dictionaries are yet another type of basket. We can represent the same thing using a dictionary. They're very similar to the name tuple we just mentioned, because we will have values which are associated with a key. And once again, since data types can be heterogeneous, we will not apply mathematical operations to dictionaries. So let's construct a dictionary in Julia. So we can use the same variable name. Basket is equal to dict. Dict is actually a function. So we have a round bracket here, another round bracket there, and each of the keys are now strings. So fruit equal superior orange. This will attribute the value orange to the field fruit. as a string n fruit equal superior to 1. And the same can be done for the bottle and for n bot. And that is what will be returned here. We have a dictionary dict with 4 entries. And you see the 4 entries. These are the keys. And on the right hand side, you see the values which are attributed to the keys. To access a dictionary, you will not use a numeric index. Unlike name tuples, you cannot do basket of position 1, but you will access by the key directly. So you can do basket, square bracket, key, it will return orange. So that's another way of dealing with, of accessing the information. The same function, keys and values, can be used. So remember, these two functions were used before for name tuples. They can be also used for dictionaries. So if you type keys of basket, it will return you all the keys. And if you type the values of basket, you will recover orange, milk, 1 and 1. So the dictionaries are a popular way of storing data, and they're used in many languages. I think particularly in Python, for example, and Julia. So it's good to be aware of how these things work. So now I want to discuss about structures. These are the most classical way to organize data, and I think you can find them in all programming languages. The main difference with tuples and dictionaries is that to generate a structure, we will not do it with one line of code. There will be basically 2 steps. First, we will need to define the structure. And this is how we're going to construct a structure. So we have to think about what is our object. So the object we want to have is a cart, basically. We want to go shopping with it, and we want to define its structure. So within the cart, we will have different items. So to construct the structure, we use the statement struct. This is the start, and we will need the end word. Next to struct, we will have the name of the structure. So this, you give it the name you want. So here, I just call it cart. And inside the structure, you can list the different types of items. So these would be field names. In the second step, we can use the structure, and we can initialize or create an instance of the structure. And this is done here. So we are going to generate now a basket. And the basket will be a structure cart, which will receive the information orange, the information milk. These are 2 strings, 1 and 1, 2 integer. So we are basically setting values to each of these fields. Orange, milk, 1, 1. This is how it's constructed. That is step number 2. You first need to define the structure cart. So if you want to access fields, you can use the dot, as we've seen before, with the tuples. So if you are name tuples, you can type here basket.fruit, and this will return you the value orange. Alternatively, there is a function called getField. It will be also very useful. So getField takes 2 arguments. It will take first the structure, basket, and then it will take the field name, but it will always be preceded by the colon symbol. So colon fruit, it will return you orange. Get field basket colon fruit returns orange. So some important notes. The structures are, of course, very popular because it's a programming tool that is basically all over the place, all different languages. In Julia, the structures are by default immutable. So what this means is that one cannot change the value of a field after it's been generated. So I cannot a posteriori change the number of bottles of milk to 2, for example. If you need to have a structure which has a modifiable field, then there is another type which is called a mutable structure. So I do not cover this in the lecture, but you basically just have to add mutable in front of struct, and then the field will be mutables. You will be able to change the values of the field. Also, once a structure is defined, it cannot be changed dynamically. So one cannot add an additional field to cart once it has been defined. Actually, this is to cart, the way we defined it. So that's one of the current limitations of structure, in my opinion. So in this lecture, we've learned about containers, versatile containers. So these are composite and flexible data types, tuples, name tuples, dictionaries, and structures. These are very useful because they will allow you to basically sort your information to get the place tidy again. Thanks for your attention.